Hello, we are Dexterous Lab. Our project is a motion tracking device that tracks the path of the peg manipulated by a patient during a functional dexterity test. Cerebral palsy is a chronic neurological disorder that affects around 17 million people worldwide. Common symptoms of the disorder include lack of fine motor control, muscle weakness, and involuntary movement. Although there is no cure for cerebral palsy, long-term patient care involving therapy and surgery can lead to improved patient quality of life. One of the current practices for monitoring cerebral palsy symptoms is the functional dexterity test, which involves observing a patient as they turn over 16 wooden pegs with one hand. The major drawback of this process is that it provides almost no quantitative data. Our system improves this process by recording quantitative details of the movement of the peg during a test. We do this through the use of an Xbox Kinect, as well as an IMU board housed within our specially designed peg. We make use of the IR and RGB cameras in the Xbox Kinect to recognize our specially designed peg and determine its approximate position throughout the test. Our peg consists of 4 color sections separated by reflective markings. The reflective markings allow the IR camera of the Kinect to quickly recognize the peg, and the 4 color sections allow us to determine the center of the mass of the peg, even if the peg is partially occluded by a patient's hand. An IMU board attached to a Wi-Fi chip is housed within our peg. This board records and transmits the peg's orientation and acceleration data during the course of a test. After the data has been acquired, it is processed by our back-end system. Our back-end system fuses the IMU and Kinect data and uses them in our invalid point estimation algorithm, which estimates the peg's position for times when it is completely occluded or outside the Kinect's field of view. This finalized dataset can then be used to graphically display the peg's position and orientation during the test. We will now show a demonstration of our motion tracking system. Before testing can begin, a few system checks and calibrations must be run. First, you run a reflection check to ensure that there are no reflective objects in the testing area other than the peg. Once the peg is removed, you are ready to move on. Next, we run a color calibration with the peg in the Kinect's field of view. This accounts for different lighting conditions and allows for Kinect to recognize the peg's colored sections during the test. Finally, we perform an IMU calibration with the peg in a set orientation. This allows us to calculate the actual orientation of the peg during the test. After these steps have been completed, you can begin the tests. Press Start to begin data acquisition. The patient can now move the peg in the desired testing pattern. After the desired motion path has been completed, press Stop to end the data acquisition. After the desired data has been captured, you can click Process Data to view the graphical display of the position and orientation data outputted by our post-processing algorithm. Our GUI is also capable of displaying an animated motion path of the peg's movement. Our system is an easy-to-use, inexpensive, and accurate extension to the functional dexterity test. We believe it will revolutionize the way diagnostics are run on cerebral palsy patients by providing quantitative motion data for doctors to analyze.